The sum of a rational number and an irrational number is always, sometimes, or never an irrational number. Well, for this one, let's start out with some examples, right? Let's say I have square root of 2 plus 5. So here's an irrational number plus a rational number. That's going to give me an irrational number. Let's say I have something else like 2 plus pi. That's a rational number plus an irrational number. That's also irrational. And let's say I have something else like square root of 2 plus 0. That's a rational number plus an irrational number plus a rational number. That's just square root of 2, so that's still irrational. Well, in these particular examples that I picked, I always got irrational, but how do I know that it's not sometimes? How do I know it's always? So for this one, we're going to do a proof by contradiction. And the way that a proof by contradiction works is you start out with some kind of a statement, and let's call this statement A. Right? So if we think A is true, then the way that a proof by contradiction works is we try to prove the opposite of A is true. Try to prove opposite of A is true. And if we can't, if the opposite of A is false, if we cannot do that, then A must be true. If the opposite of A is false, then A must be true. Okay, so that's how a proof by contradiction works. So let's try a proof by contradiction for this statement. We're going to start with A plus B. And we're going to say A is a rational number and B is an irrational number. And we want to get some result here that's rational. Okay, so I'm going to call A plus B equals C. So let's start out with A. If A is a rational number, then it can be represented as a ratio. It can be represented as a fraction, right? So I'm going to say A could be something like P over Q. Okay? And then I still have B over here. And if C is a rational number, then it can be represented as a ratio, something like M over N. Okay? So now what I'm going to do is I'm going to get the B by itself by moving the P over Q to the other side. So I'm going to subtract P over Q from both sides. On the left, I still have B, and on the right, I now have M over N minus P over Q. And these are all integers, right? These are all basically whole numbers that are either negative or positive. So now what I need to do is I need to combine these fractions. In order to combine fractions, we need to have the same denominator. So what I'm going to do is I'm going to scoot this fraction over a little bit, and then I'm going to multiply the top and bottom by the same thing. So if I multiply M over N by Q over Q, which is this denominator, I'm multiplying M over N by essentially 1, which is not going to change the number, it's just going to change how it looks. So this is going to be MQ over NQ. And then over here, the P over Q, if I multiply this by N over N, which is this denominator, then I'm going to have Pn over Q times N, which I can also write as NQ. Now I have the same denominator on the bottom. So now I'm going to have MQ minus Pn on the top, and I'm going to have NQ on the bottom. Now, we can use what we already know about integers and addition and multiplication to figure out what this is going to be. So on the bottom, we have an integer times an integer. Now, well, an integer times an integer is also going to be an integer. So that's going to be some number. And then on the top, we have a multiplication of integers, which will also be an integer, another multiplication of integers, and then we're adding or subtracting integers. So I'm going to have an integer on the bottom, and I'm going to have an integer result on the top. Well, an integer divided by an integer, that is a rational number. But remember what we said about b. We said that we were assuming b is an irrational number. Well, b cannot be both rational and irrational. So what we've done is we've proven that if we add a rational number and an irrational number, our result cannot be rational. Therefore, it must be irrational. So our answer here is the sum of a rational and irrational number is always irrational.